We have a few more examples to go, but I want to do those out of sync, so I'm not going to go for the first example up there. I'm going to go for the second example there. So, find the probability given the following z-scores of a standard normal distribution. What does standard normal mean? The average is 0 and the standard deviation is 1. If it's not standard normal, they will give you the average and they will give you the standard deviation. You put them in the calculator. Again, if it is standard normal, this is 0, this is 1, 2, 3, negative 1, negative 2, negative 3. Where does negative 0.55 lie? It's about halfway, right there. When you say, what's the probability that x is less than? Isn't that to the left? So I get my calculator out. I take my normal distribution. I want the CDF always, never the PDF. The left, doesn't that run all the way to negative infinity? So we just learned how to input. We're going to say negative 1 EE right there to the 99. That's what we're going to use. And how about the upper? So that runs all the way down to negative infinity. That's kind of what we're putting. The upper is really negative 0.55. To use this negative 0.55. Oops. Go back and delete one. Here we go. If the average is 0, if it's standard normal, we know. If not, we'll input that in. If the standard deviation is something else, we put it in. And it works the same way. And tell me what the answer is, and there it is. So there is roughly a 29.11% chance of this happening. So that probability is 29.12% chance of that happening. You could leave that in decimal as it is, no big deal. How about part B? Part B says, hey, would a probability that z is less than or equal, so here it is less than, here it's less than or equal, would that differ from A? No, it would not differ. Why is that? Because z is a continuous probability distribution. Now, giving me the z-score, you could give me the area. If I gave you the area, can you give me the z-score? Let's see what that means. Find the z-score. So I'm looking for a z-score associated with the 15th percentile. If you remember what percentile definition was, 15th percentile, that is 15%. That is 0.15. That separates the area. We're not looking at the z-score. The bottom 15% from the top, remember, this is 1. This is 100%. From the top, 85%. So what are they saying? They're saying, tell me the z-score. Tell me what this score is. So that when I look to area to the left of that z-score, I'll have a 15% area. Well, I will say P of 15 has, and I'll go to my calculator, and it's a simple minor change. If I want the area to the left of the z-score, I use the normal distribution. If I am given the probability and I want to find the z-score, I use the inverse normal. They're saying, hey, what's the area that you want? I want an area of 0.15. Are we in agreement? 0.15. Is the average 0? It's a standard normal. Yes, yes. Is this area to the left, to the right, or in between? Isn't this area to the left? So choose the left. Scroll down, paste, and give me that z-score. This tells me the z-score is negative 1. The z-score is negative 1.0 1.036. Normally it's 2 decimal places, right? That's what we use, but we could say negative 1.04. Normally the z-score is rounded to 2 decimal places. So, if they gave me a z-score, I plug it in that normal CDF. If they give me an area and ask you, so they give you the probability and ask you for the z-score, you revert the inverse of the normal distribution. Same thing here. It says, find the z-scores. I know what I have to use. I have to use the inverse normal distribution. That separates the top 10%, so they're looking for area. Let's say this is top 10%. And the bottom 10%, let's say this is 10%. From all the values. Well, 2 ways I could do this. 3 ways really. Remember, this is 0, so this graph is symmetric. Whatever score I get here, I could say it's the same up there, but it's positive. So one way of doing this is to say, you know what? Method 1 is for me to take the calculator and say, let's go by an inverse distribution. So go to the distribution, inverse normal, and I would like the area to be 0.10. It is a standard normal, and I want the area to the right. 1.28. This says it's 1.28. So you could say that's a z equal 1.28, and automatically you would say z equal negative 1.28 because they're symmetric. In this case, you just used one of those, and that's good enough. You're done. There is a couple of other ways you could do this. Method 2. You could say, you know what? I'm going to use this. I'm going to use the distribution. And the reason I'm showing you this, I'm showing you can't get it wrong. An area of 0.10. Yep. But I want the area to the left, not to the right. If they tell me this is negative 1.28, so this was using blue, I automatically assume that's negative 1.28. Here, if they tell me that this z is 1.28 negative, I could use the fact that this is symmetric and figure the top one out. And there is a third case. Now, all of these cases we're going to use, so that's why I'm showing you those. And we'll elaborate on that in our next class meeting. The third method for you to say, well, look, this whole area is 1. If this is 10 and this is 10, wouldn't that make this 0.80? Well, I go to my calculator and I go distribution, inverse normal distribution. What's the area? 0.80. And where's that area? That area is in the center. Paste, solve. Guess what? It'll give you the lower and the upper end for that. It gives you these two numbers automatically. So, how do you do this? It's up to you. But there will be problems when we're going to use the left by itself, the right by itself, and both. So it's not always you have this option. But I wanted to show you this because this is, again, extremely important. Using the calculator is a big portion of this course. And one more example to go. We're going to be using confidence level, specific notation. This is called the critical value for some confidence level. This denotes a z-score with an area to its right anytime I ask for that. Now I could use symmetry and use the left. So if I say, hey, find the z associated with a 0.05, what I'm telling you, I have an area of 5%. Can you tell me what that z-score is? Well, the z associated with that, since I'm given the area, I'm going to reverse the order, and I'm going to use second distribution. I'm going to go for inverse normal, and the area is 0.05, and the area is to the right. .64. Now, I'm not going to really keep on telling you could do this, you could do that, but again, you should be able to do area to the left, area to the right, and area in between. So that z-score is 1.65. Right? And you can check. If he gave me a z-score of 1.5 and I said, hey, what's the probability that z is greater than? I wouldn't use normal, I'll use the CDF. The area, lower end is 1.65. The upper end is 1, e to the 99. What's the area? 0.0494, which is round to 5%. And that's pretty much it for this section.